Okay, hi, welcome back. And this is trigonometry. We're on 4.5. We want to be able to graph the sine and cosine functions in the xy plane. Up to this point, we've been dealing a lot with the unit circle, and I guess you could kind of think of that being in the xy plane, but it's not really what we're getting at. We want to be able to think of the inputs and outputs of these sines and cosine functions as points, and then we want to plot those points. Okay, so before, and let's kind of introduce this and make it obvious. So the graph, we're going to start with the graph of sine of x. So up to this point before, what we've been doing is kind of thinking in terms of the unit circle. And the unit circle does not represent y equals sine x. So we just use the unit circle in order to kind of scaffold our way to the answers, right? So the circle, the unit circle in particular, is really the graph of x squared plus y squared equals 1. It's just we can define sine of x in terms of the coordinates on the unit circle. For example, this point here would be located, would be cosine of t, comma sine of t, where the t is actually then the angle from the initial side being the positive x-axis, and then on the terminal side being this line right here. Okay, so no, that's not really the graph of sine of x. What we want to do is kind of take this picture and map it onto the xy plane. Okay, so how do we do that? Well, we're going to make first a table of values. So now we're going to let x represent the angle, and then y be the sine of that angle. And I accidentally just wrote t instead of x. I want now this to be x. Okay. So we can figure out the sine of x by kind of working with the unit circle. We'll just kind of look at these four main points, these key points right here. So what's this point? It's 1, 0, and then this point is 0, 1, and then this point is negative 1, 0, and this point is 0, negative 1. Okay. So the first point corresponds to an angle of 0. Okay, so x, now it's a little confusing. We used to think of x as kind of the x-coordinate. No, now we're thinking of x as kind of an angle. So maybe I should even write that here, angle, smush that in. All right, so the first angle is 0, and we could tell what the value of sine of x is by looking at the y-coordinate. So it's a little confusing. I'm using x's and y's twice, but I really mean different things here. The y is then sine of x, which we could tell from the unit circle is going to be the y-coordinate, which is 0. Okay, so sine of 0 is 0. Let's rotate now up to 90 degrees, right? So I'm just going to rotate around the circle to here. Pi over 2, or 90 degrees. When I'm dealing at pi over 2, then the y-coordinate becomes 1. And then let's rotate around to pi, so over to here. So the output, the y value there is just 0. Then we'll rotate around to 3 pi over 2, which is 270 degrees. And the y value on the coordinate on the unit circle there is negative 1. And then if we rotate 360 degrees, or 2 pi radians, we end up where we started at 0. Okay, so what I wish to do is graph this thing on the xy plane. And let's start at 0. So on the x-axis, I'm going to put the angles, right? So pi over 2, 2 pi over 2, which is really just pi, and then 3 pi over 2, and then 4 pi over 2, which is really just 2 pi, right? And we could graph those points. So I'll put up to 1 on this axis, down to negative 1 on this axis, and let's plot the point. 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and then 2 pi, comma, 0. So back to 0. If you put in more and more points, it's going to kind of fill out the graph, and you'll have a better idea of what it looks like, but it's going to be this picture. That would be what they call one cycle of the graph, or one period, and the length of this period is 2 pi. And of course it goes on and on forever, so it keeps repeating on and on in both directions. Okay. Okay, so you can go online and find animations of this in real time. I got one queued up. Hopefully I'm not breaking any rules of copyright or anything, but here's one on the internet. Usually I have a program in my office that I use, so I'm not able to use it right now. So let's take a look at this. Am I still recording? Yeah, I'm recording. Okay. So let's take a look at the kind of the real-time version. Maybe put it in the theater mode. It looks a little nicer. Okay. So on the left, you see the unit circle, and it's going to rotate, and it's kind of generating the graph of sine of theta, or sine of x. So theta is just like x. Okay, so pretty cool. You can go online and find all kinds of cool stuff like that. But anyways, there's the shape of it, and some other details we need to know, the domain and range. So we kind of already know this. I think we've just talked about it before. The domain is going to be the set of all real numbers. And then the range, the output, the min is -1 and the max is +1. And you can see that on the picture. It never goes above 1, right? And it never goes below -1. So yeah, good stuff. Okay, so let's talk about just graphing all the variations of this. And this is kind of corresponds to what we did with translations in college algebra. So you may remember stuff like that, like horizontal shifts and vertical shifts and stretches and shrinks. You can put all of that into those terms, but the way the book does it is kind of just forgets about all that stuff. So anyways, let's jump in and take a look at what we got. Right. So graphing variations. So the first variation we see is y equals, we're going to multiply it by some number a. So a sine of x. And what is that a value? That a value, it'll be the amplitude, or in other words, how high or how low it goes. So to graph this thing, first off, you figure out what is the amplitude. And the amplitude is going to be the absolute value of that a. So in the first graph, the amplitude is just 1. Okay, the highest it goes is 1, the lowest it goes is -1. So it's not the overall distance from bottom to top. That distance is 2. It's really half that distance from bottom to top. Okay, so it's really the distance from the center of the graph. Okay. Secondly, then is getting the period. So basically the distance of one complete cycle, and for sine x, that's just this thing. Okay, that's one complete cycle. So period is how do I figure that out? Well, for now, in this case, it's just going to be from 0 to 2 pi. Later on, that may change a little, but for now, it's no big deal. And then we want the key points. The key points are going to be on this graph, those places I graphed in order to kind of get the idea of the picture, right? So let me put them in blue. This guy, 2, 3, and then I guess 4 if you want. So you could either put this guy or maybe this guy. So this looks like there's 5, but 1 is a repeat, right? So this first and the last one is kind of a repeat. So you think of it as 1, 2, 3, 4, or maybe we could think of it as 1, 2, 3, 4. I don't know. Anyways, what it comes down to is kind of figuring out your tick marks on the axis. Where do I start and where do I end, and how far do I go for each jump? Right. So in this first picture, going from this first point to this first tick mark, it's a distance of pi over 2. right? So I go by pi over 2's on my x-axis. So that the key points, to figure those out, you're just going to be taking the period, the distance of the period, and dividing it by 4. So the distance of the period in this case are the endpoints of the period, 2 pi minus 0, and then you divide it by 4, and you get 2 pi over 4, which of course is pi over 2. Okay. Right. So let's do an example. This is our, in the book, it's called Checkpoint 1, I guess. It's on page 554. And they want you to graph, let's see, page 554. This is kind of a long section. Oops, it's not 554, it's 5. Oh gosh. Sorry. One. Where are you? It's page 581. Is it? Yeah. Okay. I have no idea where I got 554 from. Okay, sorry. Just making a note of that in my notes as well. Okay. So what do we want to do? We want to draw the graph of y equals 3 sine x going from 0 to 2 pi. So basically, it's going to end up being one complete period, or one cycle. So first you get the amplitude, and basically that's just absolute value of 3, which in this case is just 3. Secondly, then you want the period. So for these beginning problems, it's always easy. It's just 2 pi, basically. You're going from 0 to 2 pi. So I should make it clear that the period, what do they want as your answer for period? They want 2 pi, okay, the length. So the period in this case is, 2 pi, technically minus 0, but just 2 pi. And then the key points, in other words, figuring out kind of the tick marks, what you're going to do is the period divided by 4, or you could go 2 pi minus 0 over 4, which is just pi. You're going by pi over 2's on the x-axis. Okay, so we come over here and kind of draw our graph. We're going to be going up 3 and down 3, so we might as well get those tick marks. And then we're going by pi over 2's all the way up to 2 pi. So 1 pi over 2, 2 pi over 2, which is just the same as pi, 3 pi over 2, 4 pi over 2, which of course is just 2 pi. Okay, so the sine form, it'll start at 0, go up, come back down, go down the -3, and then back to 0. Okay, so those are our key points, and then you just kind of connect the dots. Oops, kind of missed that one. And there's one complete cycle. Of course, it goes on forever. Okay, so that's the idea. The next type is where we have kind of a changed period. So the big change part will kind of be the period. So the variation y equals a sine of bx. Okay. So first, again, get the amplitude. I'll just write amp, and that's absolute value of a, just like before. Secondly, then get the period. So to get the period, you're going to have to do a bit of work. What you got to do is kind of wedge the bx in between 0 and 2 pi. So literally, you just take whatever is inside the sine function here, and you're plopping it right here. Okay, and that's kind of what we did before, right? We just took x, though. All it was x. There wasn't anything in front of it, and then we smushed it in between 0 and 2 pi. So it's kind of the same procedure. Now we want to get it in the form 0, x, and then something else. So to make that happen, I'm going to divide everything by b. And then 0 by b is just 0. Bx by b is x. And then 2 pi by b is just 2 pi by b. So the period is 2 pi over b in this case. Or if you would rather, 2 pi over b minus 0, but you're just going to get 2 pi over b, right? It's the length of that cycle. Okay, then thirdly, you want to get your key points or your tick marks. And it's just going to be the period divided by 4. Divided by 4. And of course, our period this time is 2 pi over b. So all over 4. To do division, you just rewrite it as multiplication. So 2 pi over b divided by 4 is the same as 2 pi over b times 1/4 times the reciprocal. Multiplying that out, you'll get pi all over 2b. Okay? And I recommend not memorizing the formulas, just memorize the process. Okay? So it's too difficult to remember all the b's and the c's and that stuff. But I think if you have this generalized process down, it's kind of the same process no matter what variation you're dealing with. Okay, so key points are going to be at pi over 2b's. Let's look at a particular example then. And this is example 3. We'll also make this the quiz question for this video. So let me make a note of that in my notes for the video lectures. So this is, oh jeez, I'm really disorganized, I apologize. 4.5, this will be your next set of homeworks. So basically video homeworks number 2. So 4.5, we want example 3. Yeah, okay. Right. So let's go ahead and tackle this guy. Example number 3. I think it's from, it is from the book. So page, I have 556 again, but it's not, is it? For some reason I like writing 556, even though it's not. 3 sine. Okay, so this is on page 583 in the book, and it's our quiz question. Okay, so what we want to do this time is to graph function y equals 3 sine of 2x on the interval from 0 to 2 pi. Okay, so first off, the amplitude, that's easy. It's just the absolute value of 3. Which of course is 3. Period then is a little different now. So to get the period, what we do is take that 2x in here and wedge it in between 0 and 2 pi. Then divide everything by 2. So you want to get an x in the middle, right? So you divide everything by 2. 0 less than or equal to x less than or equal to pi. So our period is going to be just pi minus 0, or in other words, pi. Then the key points, which are basically going to be our tick marks, is just going to be the period divided by 4, so just pi over 4. Starting at 0 and moving to pi over 2, or sorry, moving the 2 pi. Let's get the tick marks. So the amplitude is 3, so I'm going up 3, down 3. Start at 0, go by pi over 4s, all the way up to 2 pi. 1 pi over 4, 2 pi over 4, 3 pi over 4. I want to go all the way up to 8 pi over 4, right? 4 pi over 4, which is just pi. 5 pi over 4, 6 pi over 4, which is 3 pi over 2, 7 pi over 4, and then finally 8 pi over 4, which is the 2 pi we wanted. Okay, so plot some points here. It looks like we're going to get 2 complete cycles. And draw your graph. Connecting the points. Okay, so we get 2 complete cycles in there. In other words, when you multiply the inside of it by a constant that's greater than 1, it'll have the effect of smushing the graph. Because originally, with the y equals sine of x, would just be, maybe I'll put it in red, y equals sine of x would just go like this. Right. And if you smushed it horizontally, you get that effect of sort of doubling the period or doubling the cycle. You're halving the period, really. Okay. Okay. Let's look at another variation. So C. Graphing y equals a sine of bx minus c. And what this is going to do is move it left or right. Okay. So first we figure out, again, as usual, the amp, and that's just the absolute value of a. Secondly, then the period, and along with this, we're going to get a phase shift. Okay. So the phase shift is basically just telling you where you're starting. So the phase shift is basically where I start, where the cycle starts. And the period is kind of the length of the cycle. Okay, so the kind of way we do it is similar to what we did before. So what you're doing is you're wedging in between 0 and 2 pi the guts of the sine function. So before we put x in there, and then the next variation we put bx in there, and of course now what do you think we do in this variation? You're going to put that whole bx minus c in there and solve for x. Okay. When I do this method, then first I have to add c to all 3 sides. So I'll get c less than or equal to bx less than or equal to 2 pi plus c. Then I have to divide everything by b. So I get c over b less than or equal to x less than or equal to 2 pi plus c all over b. So the phase shift, I mean, what this thing represents is 1 complete cycle. It's going to start at c over b. Okay, so this is where we start, but that's also going to be your phase shift. Okay. And then this is kind of your end place on the right-hand side, the end of the cycle. The period is found just by subtracting these two. So the actual length of the period, I'll just write that over here, will be the endpoint subtracted. So the 2 pi plus c over b minus c over b, which will equal, they have a common denominator, so you just subtract the numerators over the common denominator. And what do you end up with? Well, you end up with the same formula that we had for the previous example, right? Just 2b over 2 pi over b. So the period is kind of the same. Period is 2 pi over b. And so for our key points, you can think of it as it's not like you think of these as these aren't necessarily your tick marks. Then what they are kind of you're moving by this amount every time. You're starting at c over b and then moving by 2 pi over b divided by 4. to get to your key points. So rewriting this as 2 pi over b times 1/4, which would be pi all over 2b. And ultimately then, when you go to your tick marks, you're going to start at your phase shift, which is c over b, and then you're going to add in, you're going to move, in other words, by pi over 2b. So the actual tick marks on your final graph, you start at c over b, but then you're moving by. So you're going to have to kind of multiply that b value by 2 for your ticks. It's going to make more sense once I show you an example. Okay, so without further ado, then let me show you an example. Sorry, 1 second. So is this right? Oh, sorry. So this, this is right. Okay. Okay, I think we're good. Okay, so let me show the example, and I think it'll make a lot more sense once we see this. So this is actually checkpoint 4, and we have y equals 3 sine of 2x minus pi over 3, and they just want us to graph one period, whatever that turns out to be. Okay, so the easy part is the amplitude, right? The amplitude is just the absolute value of 3. It's 3. Now we move on to the period and the phase shift. And so we take the sort of guts of the sine function and wedge it in between 0 and 2 pi. Right, so we have 2x minus pi over 3, and I'm wedging it in between 0 and 2 pi. Then I solve for x, for the inside of it. So one thing you don't want to do is combine stuff together. So when I add pi over 3 to all 3 sides, which is this step here, let me write that. So you have to add pi over 3 to everybody. On the right end, you don't want to combine 2 pi and pi over 3, or it's going to obscure what is your sort of period. Okay, all right, so we'll have pi over 3 less than or equal to 2x less than or equal to 2 pi plus pi over 3. Okay. Then I'm going to divide everything by 2, or in other words, multiply everything by 1/2. Okay, so this will be times 1/2 times 1/2. I have to distribute this one, times 1/2. So I have pi over 6, which is the phase shift, less than or equal to x, less than or equal to 2 pi over 2, which is pi. So the period is pi, and then plus pi over 6. Okay. All right, so the period is this thing. And this thing turns out to be your phase shift. Or you can think of it as this thing as the phase shift. Okay, and again, the phase shift is kind of where you're starting, and then you use this period over 4 to move to your next point. So for your tick marks or your key points, you're moving by pi over 4, but you're starting at pi over 6. So you start at pi over 6, and then to get to your next tick mark, you would add in the period divided by 4. Okay, so pi over 6 plus, in this case the period is just pi over 4. And then for the tick marks on your graph, you're going to want the common denominator of these guys. So you're going to start at 2 pi over 12, and then each time you're moving by 3 pi over 12. Okay, so find that common denominator first before you go, because you're not going to be able to put your tick marks in by pi over 4s because it's shifted by pi over 6. So this is really where you're going to start. And you're going to put your tick marks for pi over 12s. Okay. Now, sorry. Well, let's see. This is moved by this. So it'll be clear when I go to the picture. Okay. So hopefully you're ready. If not, pause the video, and I'm going to go over here and try to draw it. Okay, so the amplitude is 3, I think I said. 2, 3, down 3, 1, 2, 3. I'm going to start at 2 pi over 12. So I'm going to come over here and just call this 2 pi over 12. And then I'm moving by 3 pi over 12s. So for my 4 tick marks, I'm going 2 pi over 12, then add in 3 pi over 12. So 5 pi over 12, 8 pi over 12, and then the last one will be 11 pi over 12. Okay, so right, so it's a sine curve. So you start here at 0, and then it jumps up, and then it jumps back down, and then I guess I got to get one more after this, don't I? Sorry. So 1, 2, 3, and then it's going to end at 13 pi over 12. And then it ends right here. Okay. So hopefully that's kind of clear how I'm generating the tick marks. Seems like I should do one more example of that. And then of course it goes on and on. 1, 2, 3. So this would be at negative pi over 12 if you went in this direction, which we don't have to, but. Okay. Right. So maybe we should do another one of those. Let me get my book here. What problem was that? That was check 4. So let's do example 4. Okay, so we have y equals 4 sine of 2x minus 2 pi over 3. We just want one period. Okay, so here we go. First, the amplitude is easy. It's just 4. Secondly, then the period and phase shift. So we wedge the 2x minus 2 pi over 3 in between 0 and 2 pi and solve for x. Okay. So first add 2 pi over 3 to all 3 sides. Avoid actually adding 2 pi and 2 pi over 3 together. Divide everything by 1/2. In other words, multiply everything by 1/2. So I'll get just pi over 3 is the phase shift. And then over here it's pi plus pi over 3. Again, it's a phase shift. So the starting place where the phase shift is pi over 3, and then the period is just plain old pi. Okay. Then for my tick marks, or my key points, I'm starting at pi over 3, and then I'm adding in the period divided by 4. So for my tick marks, I'm going to be going by, let's see, I'm going to start at finding a common denominator, right? So of 12, so I need to multiply top and bottom of this guy by 4. So 4 pi over 12. And then for the second guy, I need to multiply top and bottom by 3. So this would be 3 pi over 12. So I'm starting at 4 pi over 12, which is the same as pi over 3, and then I'm moving 3 pi over 12s every time. So let's draw that. So you can go like, what is this, 4 pi over 12, and then move by 3 pi over 12. So this would be 7 pi over 12, 10 pi over 12, 13 pi over 12, and finally 16 pi over 12. Okay, and then get your key points. I think the amplitude was 4. So for one period, we're just doing this kind of picture. Okay, and then of course it goes on and on. Okay, let's move on then to cosine. Okay, cosine, if you remember, is just kind of a shifted version of sine. It's just if you remember our cofunctions from before, you can rewrite sine as cosine just by kind of adding in a 90-degree angle, right? So the graphs look almost exactly the same. Let's think of it in terms of the unit circle again. Okay, where the cosine is kind of the x-coordinates of these points. So this is 1, 0, 0, 1, -1, 0, and then 0, -1. And then we want to go x, y, where y is equal to cosine now. Okay. So cosine of x. Okay, so the angle 0, when we're at 0, you're kind of at 1, 0, so the x-coordinate is 1. At pi over 2, when you rotate over the pi over 2, the x-coordinate is 0. At 2 pi over 2, in other words at pi, the x-coordinate is -1. 3 pi over 2, or 270 degrees, the x-coordinate is 0 again. And then finally back to 2 pi, and of course you're at 1 again. So the picture then, we start at 0, going by pi over 2's this time. And 4 pi over 2 is 2 pi. Amplitude is going to go from -1 to 1. The amplitude is 1. So it starts at 1 this time, and then it goes to 0, and then it goes to -1, and then back to 1, and then all the way up to 1. And if you make it look kind of curvy, and it looks like this. And then if you keep on, it would keep on going on and on forever, doing the same thing. Okay, so this is one complete cycle of cosine, or one period if you wish, and the length of the period is always given as 2 pi. Okay. So the only thing that really changes now is when we go and do our graph, the key points are different. It starts at the top and then goes to 0 and then goes down. Okay, that's the only thing that's really different. So we can kind of skip right to the punchline and worry about variations, or graphing these ultimate variations. Graph y equals a cosine of bx plus c. Okay, okay, so let's try one. This is example 6. And we're trying to graph y equals 1/2 cosine of 4x plus pi, and I need to graph one period. Okay, so again, you get your amplitude. All this stuff's the same as before. Amplitude is the absolute value of 1/2. Secondly, the period and the phase shift. Usually the phase shift is just 0, right? You just start at 0. But for these phase shift, looks like we're going to start at -pi. Right? Or it'll end up being negative pi over 4. So let's look. Wedging all that material in, what is it? 4x plus pi, and we wedge that in between 0 and 2 pi. Right? So the guts of the cosine function, you just take 4x plus pi and put it in between 0 and 2 pi, and then solve for x. Okay, so subtract pi from all three sides. Divide everything by 4. In other words, multiply by 1/4. So yeah, the phase shift negative pi over 4. And the period 2 pi over 4 is pi over 2. Okay. So the period is pi over 2, and the phase shift is negative pi over 4. Okay. What else then? The key points, or the tick marks, is kind of how I think of it. So you're going to start at negative pi over 4, and then you're going to be adding in the period divided by 4. Okay. So what is that? Negative pi over 4 plus pi over 4 divided by 4 is the same as pi over 4 times 1/4, which is pi over 16. Then we need a common denominator. Looks like it's going to be, oops, the period is pi over 2. I got carried away there, sorry. So this is pi over 2, so it's pi over 8. Sorry about that. Okay, so the common denominator is going to be 8. So negative 2 pi over 8. And then you're moving by pi over 8s. Start at negative 2 pi over 8 and then move by pi over 8. So let's go over here and kind of figure that out. So negative 2 pi over 8, and then move by 1 pi over 8. Yeah, so this would be negative pi over 8, and 0, and then pi over 8, and then 2 pi over 8, and then 3 pi over 8. I don't know how far we need to go. Okay, so it's a what was it, sine or cosine? It's a cosine function, so you start up. Normally you would start at 1, but the amplitude is 1/2, so we're starting at 1/2, and then we go to 0, and then down the negative 1/2, and then back up, and then so we get the full period. It's going from negative 2 pi over 8 to positive 2 pi over 8. And if you wanted to keep going, we sort of started that process. Okay, so that's kind of the idea here. Let's move on to the last part. So we've done basically horizontal shifts, vertical shifts, vertical stretch and shrinks, horizontal stretch and shrinks. We need the vertical shifts. Okay, so going up, moving the graph up and down is kind of the last section in these notes. And basically what I recommend doing is just do kind of everything you did before and then move your result up or down by this d amount. Okay, so your formula is going to be a sine or even cosine, one or the other, of bx plus c. So we know how to graph that. So you're going to graph that. And then you're going to move all the points up or down by d. Okay? So you're going to move up if d is positive. And then move down. if d is negative. Okay, so let's look at one of those. This is actually checkpoint 7 in the book. And it's y equals 2 cosine of x plus 1. So it's not that hard. First, get the amplitude. So the amplitude is the absolute value of 2, which is 2. Secondly, your period and phase shift. Okay, so you just take the guts of cosine and wedge them in between 0 and 2 pi. No work to do here. The period is 2 pi. The phase shift is 0, so there's no phase shift. Thirdly, then, you're getting your key points, so you're just taking the period and dividing by 4 this time. If you want to think of it as a starting place plus some number, the starting place is 0, and then you're adding in the period, which is 2 pi, divided by 4, so you end up with 0 plus pi over 2. So you're basically going by pi over 2's starting at 0. Okay? So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi, which will give us 1 period. Okay, okay, and the amplitude again is 2. So I kind of completely disregard that plus 1 on the outside here, this part, and just graph it as it is at first. So let me put that in a different color, or I'll put it in blue. Okay, so it's a it's a cosine, so it starts like here, goes here, then here, then here, then here. And now I kind of get the plus 1 part. So the plus 1 is positive. It means just shift all of those dots up 1. Okay. So your end graph is going to be here. Oops, I didn't stretch it. Sorry. Sorry. Okay, so again, by pi over 2's, I forgot the amplitude. Okay. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 is 2 pi. The amplitude is 2. So your little dots originally should be here, 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 and here. Okay. What I'm saying now is, rather than graph it, just shift all those dots up by the d value. So the d value here is positive plus 1. So just shift all of these guys up 1 place. That will go there, that will go there, this will go here, this point will go here, and this point will go here. And then connect your dots, and you have your picture. Okay. And then, of course, it goes on and on. We just wanted 1 period. Okay, let's look at some applications. So in some problems, what they're going to do is give you the graph, and then you have to make up the model. In other words, make up the equation. And in real life, you know, your x-axis isn't going to be in pi, in terms of pi. They generally will want it like 1, 2, 3, 4. Okay, so we'll look at example 8 in the book. And example 8 is on page 593. Okay. The graph shows 1 complete normal breathing cycle. Okay, so there's kind of this in, out, inhaling and then exhaling. So it's going to go up to 0.6. So I'm going by 0.1s. 1, 2, 3, 4, 5, 6. 6 and down. 1, 2, 3, 4, 5, 6. Negative. And what the y-axis represents is the velocity of airflow. Okay, so it's kind of hard for me to write sideways, but air flow velocity. Okay. On the x-axis, we have time and seconds. And what they're saying is the figure shows one complete normal breathing cycle. Okay, so 2, 3, 4, 5, over 5 seconds, I guess. And they're listing the x-intercept a little beyond 2. So it's going to look like this. Not exactly sure where it peaks out, you know, what's the x value such that the graph is highest. I don't know. It's kind of in between 1 and 2 maybe. So anyways, the graph shows one complete normal breathing cycle. The cycle consists of inhaling and exhaling. It takes place every 5 seconds. Velocity of airflow is positive when we inhale and then negative when we exhale. It is measured in liters per second. If y represents the velocity of airflow after x seconds, find a function in the form y equals a times sine of bx that models this airflow. So you can imagine having to do this, working at the CDC, and they're, like, some of the research is saying that English speakers exhale more when they talk than non-English speakers. So that's a real issue for us English speakers and the spread of the virus. Anyways, first we would need sort of an amplitude, and you can tell what the amplitude is, right? From the low point to the high point, it looks like it's, what is it? You know, what's the difference between the low and the high? It's 0.6 minus negative 0.6 is 0.6 plus 0.6, which is 1.2. For the amplitude's half of that, right? So the amplitude is going to be 1.2 divided by 2, which is just 0.6. So I guess you could kind of look at the picture and tell that. So maybe I did an overkill there. Secondly, then, we need the period. It doesn't look like there's a phase shift, right? So one complete cycle starting at 0 and ending at 5. So if we were to kind of figure out our formula, we would end with this expression, 0 less than or equal to x less than or equal to 5. But the way we start, given this form, is wedging the guts of the sine function, the bx, in between 0 and 2 pi, and then solving for x, right? So to solve for x, we just divide everything by b, and you can engineer sort of the equation you need to solve. So we would have 0 less than or equal to x less than or equal to 2 pi over b. In other words, we want 2 pi over b to equal 5, right? We want 2 pi over b to equal 5. And we could solve this for b. We just multiply both sides by b, divide both sides by 5. You know, so we get 5b equals 2 pi, divide by 5, and b will be 2 pi over 5. Okay. We don't need anything else. We just needed the a and b values. So our model will be y equals 0.6 sine of 2 pi over 5x. Okay. Let's look at a harder one. Let's look at, I guess this is example 9, and they talk about modeling the tides. So we have 5 feet at low tide, and it goes all the way up to 13 feet at high tide. Low tide happens at 4 a.m. and low tide happens at 10 a.m. They give you a graph, and let me try to draw that. So I need to go up to 13. 2, 3, 4, 5. Let me get the good numbers. So 5 is important. 6. think 7 is important as well. 6. Yeah, it is. 6, 7, 8, 9, 10, 11, 12, 13 is important. And then on the x-axis, 4, 10, and 16. 1, 2, 3, 4, 5, 6, 7, I think is important. 8, 9, 10, 11, 12, 13 is important. 14, 15, 16. Okay. And then the picture looks like has 4, 5. It's kind of there. 5, 6, 7, 8, 9. It's kind of in the middle. So 7, 9 is kind of important. 10, 13 is all the way up. 13, 9, and then 16. That's where it goes back down to 5. And I'm going to need some more marks here, sorry. I need to go all the way out to 22, apparently. 16, 17, 18, 19, 20, 21, 22. Halfway, 16, 17, 18 is 19. And 19 is going to put us back here. Then 22, we're way back up here. The important bits are kind of like the sine function right here. This part. Okay. And, all right. Okay, so again, we want a formula. We want to model this, the action of the tide with a formula in the form of y equals a sine of bx minus c plus your d value, okay, because there's a shift upwards. Okay, so first off, the amplitude. And for the amplitude, you just take kind of the distance between the lowest point and the highest point, and then subtract the two. So the highest point is here at 10, 13. That's what that 13 feet at high tide meant. So at 10 o'clock, this is time on the x-axis. At 10 a.m., it's 13 feet high. And then at 4 a.m., the other low point over here, it's going to be 5 feet high. Okay. So the amplitude is just the difference between the heights, 13 and 5, and then divide it by 2. So you still have to divide it in half. 13 minus 5 divided by 2. What do we have? 8. 9, 10, 8 divided by 2, which is 4. So the amplitude's 4. A is 4. Okay. Then we need to get our period and phase shift. And we can do some back engineering. I could tell in the end, oops, the thing is starting at 7. Okay, that's where the main cycle for the sine curve starts. Starting at 7. And then the period, it seems like, the phase shift is 7, and then the period is from 7 to 19, right? So on the other side, you should have 19, I guess. But you could rewrite that in terms of kind of the length of the period is 7 minus 19, right? 19 minus 7 is the length of the period, and then plus the phase shift. Okay. So it's really going to end up being 19 minus 7 is 12, and then plus 7, just to keep it kind of in order with what we've been doing already. Okay. So this is the phase shift. and then this is the period. 12 is the period. Okay, so anyways, what we want to do then is kind of back engineer this ax plus b, because that's where, where we would have started, right? Okay, so let's see if we could do that. First, I would want to subtract 7 from all three sides. Well, no, what you want to do first is you have to go in reverse, right? So you need to get that a value. So you need to multiply everything by this a value. So you'd have 7a less than or equal to ax, less than or equal to 12 plus 7 times a, I guess. Maybe we should just put 19 in there. So this would be 19a. And then add b to all three sides. So I'd have 7a plus b less than or equal to ax plus b less than or equal to 19a plus 2 pi. So what will that give me then? Well, this part has to be the same as this part, right? And if we equate those, we'll be able to figure out a. Once we get a, we can say, well, this part has to be this part. 0 has to be 7a plus b. We can put in a and figure out b. Okay, so first off, this part. 2 pi has to equal 19a plus 2 pi. Okay. So 19a will equal 0, and I've screwed up. Sorry. What did I do? So I want to start, down here, and then I'm constructing. What did I do wrong? Sorry, I'm going to pause the video for a second. Oh, I see what I did. It's right here. I still only added 2b in here. You're adding b to all three sides, so this should be b. Okay, so first off then, sorry. This is b. Okay, so let's see. 19a. Let's solve for b. That'll be easier. So b will equal 2 pi minus 19a. And then use this formula here. So you know that 7a plus b will have to equal 0, right? So you could solve this for b, or even solve it for a if you wish, but it's probably easier to solve for b, I guess. b is negative 7a. And then plop that into, I guess we could just plop it into here. Maybe it'd be easier to put it in here. And we probably don't even need this equation then. So I'm going to plop it in there. And I get 2 pi equals 19a minus 7a. Right. And then 2 pi will equal 12a. So a will equal 2 pi over 12, which is just pi over 6. And then for b, just use this formula. So b will equal negative 7 times pi over 6, which will be negative 7 pi over 6. So it's back engineering to get to your formulas from the sort of process that we developed in this video. So at the end of the day, y will equal the amplitude, which we figured was 4, times sine of a, which is pi over 6x, minus plus b, which is minus 7 pi over 6. Okay. So when I wrote this form, it should be bx plus c is the way I think we introduced it. So I just want to be consistent. Yeah, okay. All right, so that was a long section. I apologize for how long it is. The next section, then we'll need to go in and worry about the other functions, the tan function and the secant function as well. Okay, but that'll do it for this video. Thanks for watching, and we'll see you next time.